Hi students, have a great day. Let's start with our second chapter, polynomials. So polynomials means it has many terms, okay, and it will be of this form an xn, an minus x minus 1. So what are this an, xn and everything? X is the variable, okay. So this is a polynomial in variable x, and it can be y also, z also, anything that is called as a variable, and that's a polynomial in the corresponding variable. So what is a1, a2, etc. are constant or real numbers, any real number. Constant means any real number it can be, okay. So then what is n? N is a positive, any positive integer. So if I give an example, you can understand. Suppose if I am writing f of x is equal to 3x square, 3x cube plus 4x square minus 3x plus 9. So this is a polynomial. So what is this? A1 is 3. Okay. So these are all constant or any real number. Okay. So x is the variable over here. So these are the exponents. Okay. And then what are the terms and coefficients? So how many terms are here? The terms is defined as anything separated by plus or minus. Okay, so this is the first term. See, if I am writing here again, 3x square plus 4x minus 3, anything separated by plus or minus, this is called one term. This is the second term, and this is the third term. So this polynomial has three terms. Okay, so what is coefficient of, if what do you mean by coefficient? Coefficient of x square, if I am asking, leaving x square, whatever is there in this, that is called coefficient. So coefficient of x square in this is 3. So what is the coefficient of x in this? It is 4, and the constant is minus 3. You have to take along with the sign, and constant is minus 3. Okay, because the general form is ax square. For if it is a quadratic, then it is ax square plus bx plus c. So if there is minus, you have to take minus also for the constant. Is this clear? So the polynomial will be of this form, and this is one of the example. And polynomial, these things are real numbers, any real number will be there. And if whatever we are using, suppose if it is x, then it's a polynomial in variable x. You can take y also, z also, whatever it be, the polynomial in the corresponding variable. The power of this is the exponent, and number of terms. So each and everything which are separated by plus or minus is called one term. So this has three terms. Okay, so coefficient of a variable means, suppose if I am taking the coefficient of x square, it is 3 here. Coefficient of x means leaving that x, whatever is there here, that is called coefficient. Just remember in this way, because at times students get confused. If I am writing like this, x square minus 4a square x plus 7. So what is the coefficient of x? You cannot tell as minus 4, because leaving x, leave x chhod ke, whatever is remaining, that is called as coefficient. Okay, even a is a constant here. Okay, you have to take that also. So you have to understand the coefficient is, if you are asked for x square, leaving x square, whatever is remaining is the coefficient. If it is for x, leaving x, whatever is remaining along with the sign. Okay, if the sign is negative, you have to take that also. Okay, that is called coefficient. Now the next one is degree of a polynomial. If I am writing x square plus 2x, 3x plus 2, you know this is a polynomial now. What is the degree of a polynomial? The highest exponent in the whole thing is called the degree. So here the degree is 2, because that is the highest exponent. This power is 1, this power is 2. So what is the highest power? 2. So the degree is 2. Okay, the highest degree term in the polynomial is known as exponent. Okay, highest exponent is called as the degree of the polynomial. Suppose if I am writing like this, what is the highest degree? It is 1. So this is the degree of the polynomial. Okay, so next one is, yes, polynomial can have any degree. So if it is having a degree 0, what is the meaning? There is no variable at all. The polynomial is like this. f of x is equal to 5. That means it is just a constant. There is no variable in this. There is no x term, y term or any exponent over here. Such a polynomial has a degree 0. Okay. So the polynomial of degree 1 is called as linear polynomial. Suppose if I am writing like this. What is the highest power? Highest power is 1. So the degree is 1. So the polynomial of degree 1 is called as a linear polynomial. What is the general form of this? You can see from this and tell. Y is equal to, this is some constant. So ax plus again another constant. Provided a not equal to 0. Why? Because if a becomes 0, only b will be remaining. That means it will come under the polynomial with degree 0. It will have only constant term, no? See, if the a becomes 0 here, it will be 0x plus b. That means this term will vanish. Only b will be remaining. So if b is remaining, this is nothing but constant. What is the degree of the constant? There is no variable. So the degree will become 0. So for a linear polynomial will be of the form ax plus b, and a and b are any real number, and a should not vanish. A should not be equal to 0. If a is 0, the x term will vanish. Okay. So that is the thing given. So next one is quadratic. You yourself can understand what is quad means 2. So quadratic means the degree should be 2. Okay. So if I am writing y is equal to 3x square plus 9x plus 6. So what is the highest exponent here? The highest exponent is 2. So what is the degree then? The degree is 2. Okay. So what is the general form is y is equal to ax square plus bx plus c. Okay. So a, b, c are again real numbers, and here also a should not vanish. A not equal to 0. Why? Again the same explanation. If it becomes 0, the x square term will vanish. Then what will be remaining? Only this will be remaining. If this is remaining, what is the degree? Degree will become 1. Then it will be a linear polynomial, not a quadratic polynomial. So a should not be equal to 0. Okay. So now you can very well say what is cubic. Cube means 3. So the polynomial with degree 3 is called as a cubic polynomial. Okay. So what is the general term? It should have a cube term. Okay. So y is equal to ax cube plus bx square plus cx plus d. So again what are a, b, c, d? A, b, c, d are any real number. And here which term should not vanish? Cube term. Because if it becomes 0, it will become a quadratic polynomial of degree 2. So a should not be equal to 0 again. Is this clear? Okay. So next one is 0 of a polynomial. So what is the meaning of 0 of polynomial? If in a polynomial, if I substitute something for x, and if the value turns out to be 0, then it is called 0 of the polynomial. Suppose if I am substituting minus 1 here. So minus 1 square minus 3 into minus 1 minus 4. So this is equal to 1 plus 3 minus 4. So which is equal to 0. Getting? I am substituting some value for x in this given polynomial so that the value of the whole polynomial becomes 0. Then that value minus 1 is called as the 0 of the polynomial. So minus 1 is the 0 of the polynomial. That is the value, any real number on substituting over in this polynomial. If the value of the whole polynomial becomes 0, then it is called 0 of the polynomial. Okay. Suppose if I am substituting 1 here. So it will become 1 square. I am substituting 1 in this x. Okay. So minus 3 into 1 minus 4. So what is the value? 1 minus 3 minus 4 minus 7 minus 6. So this can be written as f of x at x is equal to 1 equal to minus 6. See here, this is the polynomial f of x. What value we have substituted? x1. And what is the value? Answer we are getting minus 6. So this line is mentioned as, this can be told as at. So f of x at x is equal to 1 is equal to minus 6. Okay. So this is the value of f of x at x is equal to k, where k is any real value in general. Okay. Is this clear? 0 of the polynomial and value of the polynomial at any point. Okay. So next one is geometric meaning of the zeros of the polynomial. So what is the geometric meaning means? Always we plot in the graph. Okay. So we have found the 0 of the polynomial. Then we are going to plot that and see how it is represented in a graph. Okay. So first I am considering the linear polynomial. You have studied now what is the general form ax plus b. Suppose I have to substitute something over here in x and should get 0. See, the polynomial is ax plus b. I have to substitute some value here and should get the answer as 0. What value should I substitute here? Ax plus b is equal to 0. So ax will be minus b. So x is equal to minus b by a. So if I substitute the value of minus b by a in this, then the polynomial will become 0. Is that or not? Minus b plus b, it will become 0. This you can mathematically calculate. Now I am going to calculate graphically. I will take some value for x, random values. I have taken 0 and minus 1. Okay. So and then put that value x, 0 here. So 2 into 0 minus 5. The value will be minus 5. I substitute 1 here. 2 into 1 minus 5. I'll get minus 3. Getting or not? See, first I am substituting value 0 and I am getting minus 5. So y value will, when I substitute x 0, y value is minus 5. Now I am substituting 1 here, then the value will be minus 3. So this is the value we got. Okay. Now I am going to plot this in a graph. Okay. Here it is 0. X-axis I am taking 1, 2, 3. This measurement is may not be proper. It's just for your understanding I am drawing. It's not a proper measurement. Okay. So minus 4, and here you will get minus 1, minus 2, minus 3. We need up to minus 5. Okay. So I'll little bit here. Okay. So here in the top also you will get 1, 2, 3, 4, 5. Okay. Something like that. So I have to plot 0, minus 5. X-axis 0 and y-axis minus 5. Somewhere over here 0 and minus 5. Okay. So then what we have to plot 1 minus 3. Okay. So 1 here and minus 3 somewhere over here. Just for a understanding, it may not cut at the exact point, but I have to demonstrate you. See here. So extend this graph till the please make it in a straight line. Okay. So if I extend, this point will be minus 2.5. I'm sorry, plus 2.5. Okay. So it will cut the x-axis at one point. That point is, suppose if it is 2.5 and the y value is 0. Okay. So if this is done, you can understand what are the things you can infer. This linear graph will always be a straight line. Please consider this as a straight line. I can't draw straight here. Okay. So this linear graph will always be a straight line, and the point where it cuts the x-axis is the 0 of the polynomial. Why so? Because the value of y, whenever it cuts the x-axis, what is the value of y? In this whole line, the value of y is 0, right? So when the point where it cuts the x-axis, that value will give you 0 of the y. Getting? If you are calculating here manually, so what will happen, like not graphically, just algebraically, see here 2x is equal to 5 by 2, x is equal to 2.5. So at this point you will get y value as 0, right? The same thing we have calculated graphically. Why it is like the point where it cuts the x-axis is 0? Because the whole line is 0 here. That means this is the value of y, this is the value of x. So if I substitute 2.5 here, then the value of y become 0. So this is the 0 of this polynomial. Is this clear? I have seen some students who by heart at wherever it cuts the x-axis, that is the 0 of the polynomial. But if we ask why, they can't understand. So I am explaining this. Please understand. Why it is like it cuts the x-axis means the value of that is the 0 of the polynomial. Why? Because the whole line it is 0, y value is 0. If it cuts the x-axis, suppose if it cuts here, then minus 4 comma 0. So that means if I substitute x minus 4, the value of y is 0. So this minus 4 is called the 0 of the polynomial. And what are the things we have studied? Linear polynomial will always have a graph of straight line, and the point where it cuts the x-axis is the 0 of the polynomial. Algebraically, mathematically, you can calculate this. This will always be minus b by a. Okay, done. Yes. Next one, quadratic. So how the graph of the quadratic will be? This is of the form y is equal to ax square plus bx plus c. Okay, so this graphically we are going to represent. I have taken some random values, and you can here itself you can see where what is the 0 of the polynomial, 4 and minus 2. Okay, so but to demonstrate the graph, we will draw the graph. Okay, I think y-axis I should take minus 2, 4. We'll take 2. Okay, 2, 4, 6, 8, and then 10. Here also it goes till 16. We'll cut. Okay, minus 1, minus 2, minus 3, like this, and then here 1, 2, 3, 4, 5. Okay, so now first we'll start from here, 4, 0. So this is the point over here, 4, 0, and 3 minus 5, somewhere around here, 3 minus 5, and then 2 minus 8, here 2 minus 8, and then 1 and 9, 1, 9, 0 minus 8. Okay, so here 0 minus 8, and then minus 1 and minus 5, somewhere over here, minus 1, minus. You can draw on a graph and see. Okay, so I'm just approximating this, right? Okay, so then what we did, minus 1, minus 5, then minus 2, 0 will be over here, minus 2, 0, and then minus 3, 7. So somewhere above this, it is only 5 till here, please mark somewhere over here, minus 3, 7. Okay, done. So now what I am going to do, I am going to connect all the points whichever we have marked. See, this is a U-shaped graph. Okay, like this it should come, U-shaped. So U-shaped graph is nothing but a parabola. Okay, so the parabola where it cuts the x-axis, whichever it be, where it cuts the x-axis is the 0 of the polynomial. Why? On substituting 4 in this equation, see here, if I substitute 4 in this, then like that only we have found this value. Okay, 16 minus 8 minus 8, so 8 plus 8 minus 8, so it will get 0 over here. So I am substituting this value in x-axis and getting the value of y-axis, for which I am plotting this to check how the curve is and where it cuts the x-axis. Okay, so quadratic will of this form, y is equal to ax square plus bx plus c, will always have an upward u-curve or downward u-curve. Okay, so this can be of this form only, and where it cuts the x-axis, 4 and minus 2. On substituting this, you will get the value of y as 0. So these are the zeros of this quadratic polynomial. Okay, so in general, the graph y is equal to ax plus c can have 2 zeros, 1 0, or no 0. In the previous example, how many zeros we have? We have 2 zeros. Okay, so like that it can have 1 0 also. How can be 1 0? How the graph will be? It can be like this. That is, it cuts the x-axis. Suppose if I consider 2, it cuts the x-axis at only one point. That means it has got 1 0. It can be pointing downwards also, no issue, like it can point like this also. So it cuts the x-axis at only one point, then it means it has 1 0. So no 0 graph, how it will be? It can be like this. That is, it won't cut the x-axis at any point, so then it is no zero graph, okay, polynomial, right? So how you are getting into the no zero, 1 0, 2 0? Suppose I'm taking this example, okay? So you know, to split this term, middle term, you remember those factorizations. See here, this is 8, the coefficient is 1, so 8 into 1, 8, and then here I am having minus 2. So I have to take two values in such a way, if I multiply that value, I should get 8. If I multiply that, I should get 8, and if I add that, I should get minus 2. Okay, so this is way you can factorize this. So which are the two numbers? 4 and 2. If I take minus 4 and it's minus 8, okay, so minus 4 and 2, I will get minus 8, and if I add minus 4 plus 2, I'll get minus 2, okay. So here I'll split this in the way x square minus 4x plus 2x minus 8. Can you understand? I have taken minus 4 and 2. Minus 4 plus 2, I will get minus 2. If I multiply minus 4 and 2, I'll get minus 8. This is the way we factorize, okay. So now I take x common outside. Here also I need x minus 4 here. So here 2. So x minus 4 into x plus 2, okay, equal to 0. Then x is equal to 4 or x is equal to 2. So this two values, minus 2, sorry, x is equal to minus 2. In this we get zeros. This is what we have seen in the graph also. 4 and minus 2. In this we get zeros. So this are the zeros of the polynomial. If we can factorize and find the two values, then it will have two zeros as in the previous example, okay. So if I factorize second example, see here, y is equal to x square minus 6x plus 9, then I have to multiply and get two numbers and get multiply two numbers and get the value as 9, and add and get as minus 6, okay. So what three numbers or two numbers? 3 and 3, okay. So minus 3x minus 3x, if I add I will get minus 6, and if I multiply I will get 9, okay. So then x into x minus 3, so here also I need x minus 3, so I will take minus 3 outside. So the factors will become x minus 3 into x minus 3. So what are the values? X is equal to 3 or x is equal to 3, okay. So that means the value is equal, the value of x is equal on factorizing. So then it means it will cut at only 1 point, only 1 point. There is only 1 0 for which there is only one value for each which it becomes 0. If I substitute 3 here, it becomes 0, okay. 9 minus 18 minus 9 plus 9, 0. For only one value of x, this polynomial becomes 0. So there is only 1 0. That means the graph will cut either this like this or this, anyway it will cut the x-axis at only 1 point, okay. Is this clear? How we are getting two zeros, how we are getting 1 0. Another one is no 0. Here we can't factorize and find the value of x, it will be in some root, okay. So this we can say like x is equal to minus b plus or minus root of b square minus 4ac by 2a. So this is called the d term. If I calculate this value and if it is less than 0, then it means it has no roots. The roots will be like, see here, I'll calculate and show you. So minus b, this is ax square plus bx plus c, okay. So what is b? B term is minus 4. So minus b is minus of minus 4 plus or minus root of b term is 416 minus 4 into what is a term. I am taking this example, please understand. Y is equal to 2x square minus 4x plus 5. So a is equal to 2, b is equal to minus 4, c is equal to 5, okay. So my b is minus 4. So minus b is minus of minus 4 plus or minus b square 16 minus 4 into what is a term? A term is 0, c term is 5. So here 5. Okay, then 2 into a term is 2. So if you calculate this, see, only if you calculate this also you can understand. 22s are 40. 16 minus 40, you are getting some negative term in this. 24. Okay, so you are getting 4 plus or minus 24, minus 24 by 4. So in this way, can you find the root of this? This will become a imaginary number. When you're having root minus inside the root, it will become an imaginary number. That is, we cannot find any value of x for which this equation becomes 0. This y value we can get 0. So such a type of polynomial has no 0 and the curves will never touch the x-axis. Can you understand? See, first how we are getting two zeros? See here. If you are getting two values of x for which the polynomial becomes 0, then the graph will cut at 2 points like this, either upward or downward, anywhere. It will cut at the x-axis at 2 points. These curves are called parabola. You will have in 11th standard in detail. So here you just understand it's a parabola and it will be opening upward or downward for such a type of equation. Okay, so it will cut the x-axis at 2 points when we have two values of x which satisfies the which makes the equation polynomial value to become 0. When we have only one value, that means both the value are same, both the factors are same, then we'll have only one 0. It will touch the x-axis at only one point, either upward or downward, and we can't have any zeros. That equation will be, that factors will, we can't find the value of x such that the polynomial becomes 0. How to find out? See, you can use this formula to find out the value of x. Okay, so minus b plus or minus root of. If the root has minus term in this, then it is an imaginary number, so we can't find the value of real number x that makes the equation y is equal to 0. Okay, so in that case the parabola will never cut the x-axis. Okay, next one is cubic polynomial. So cubic polynomial, how the graph will be, again we have to take some random value of x and y. On taking the random value of x and substituting here, see, minus 2 cube minus 4 into minus 2, 8 plus, sorry, here minus 8 plus 8. So this value becomes 0. So like this we have to take some random values and find the value of y, and then again plot in the graph. There is some 15. Okay, let us take 5, 3, 6, 9, 12, 15. Okay, because we are getting 15 over here, I am taking as one point as 3. Minus 9, minus 12, minus 15. Okay, so here 3, 6, 9, 12, and again some 15 over here, and then minus 3, minus 6, minus 9, minus 12, and minus 15. Okay, so if you plot the graph, the graph will be somewhat like this. So that means it touched the 3 points. Okay, so then it means the zeros of this is, you can plot and see 3 zeros over here. Okay, so next one is, so in general this cubic polynomial has 1 0, 2 0 or 3 zeros. Okay, so the graph for 1 0 will be like this. It will cut the x-axis at only one point. The graph for 2 0 will be like this. It will cut the x-axis at 2 points, and the graph for 3 zeros will be like this. It will cut the x-axis at 3 points. Okay, so next, coming to the exercise, the graph of y is equal to p of x. So on seeing the graph, we have to say how many zeros are there. Okay, so this graph doesn't cut the x-axis at any point. That means the number of zeros is equal to 0. Why? Because it doesn't cut the x-axis at any point. Second one, this graph cuts the x-axis at 1 point, so the number of zeros is equal to 1. So this graph cuts the x-axis at 3 points, 1, 2, 3, and so the number of zeros is 3. And this graph cut the x-axis at 2 points, so the number of zeros is 2. Likewise, this graph cuts the x-axis at 4 points, so the number of zeros is 4. And this graph cut the x-axis at 1, 2, 3 points, so the number of zeros is 3. So now you can understand why, if it cuts the x-axis, why it is called the zero of the polynomial. This I have explained you clearly. Please see again if you can't understand. So don't by heart like if it cuts the x-axis, that is the zeros and that is the number of zeros. Just understand why. Okay, so here in the cubic polynomial we can have 1 0, 2 0 or 3 0, and the graphs are like this. And this is of one of the example of the cubic polynomial. Okay, so we have seen the quadratic and linear and then degree of the polynomial and what is the polynomials. This is just to give a quick recap. I just did this. Okay, with this our first exercise is over. Thanks.